Okay, so here's other kinds of things I can ask you about understanding the relationship between f, f prime, and f double prime. Okay, I could give you a graph of f, okay, and I could ask you a question about what's f prime doing here, what's f double prime doing here. Imagine, it's sort of hard for me to draw with these tools, so imagine this is a nice smooth curve. I know it doesn't look really that smooth. Ooh, that's a little better in my drawing. But what I should see is that it's concave up, okay? Doesn't have any turning points, doesn't have any inflection points, right? This looked like the coronavirus when we were all locked down in March of 2020, right? This was what the coronavirus was doing. That is because the second derivative, right, if I'm concave up, what I know about the second derivative is that it is positive. Anywhere the graph is concave up, the second derivative is positive. The reason we were freaking out, right, back in March of 2020 is the rate of change. The first derivative, anywhere that the original function's concave up, the first derivative is increasing. So I could say something like this data, not only is the coronavirus increasing, but it's increasing at an increasing rate, right? And then what happened is we were hoping to get, and we finally did get to it, this inflection point, right? The inflection point was the flatten the curve point, right? Where the number of new cases got to a maximum. Right? That's because at an inflection point of f, and again, those are all like fill in the blank things, right? Like an inflection point of f is, right? That's a turning point of f prime. Right, so that means the rate of change, if this were coronavirus, the rate of change just went from an increasing rate of change to a decreasing rate of change. Cases are still going up, but now they're going up at a decreasing rate, right? Because concave down, the rate of change is decreasing. So an inflection point of f is a turning point of f prime, so in this case it's a maximum, right? That was the maximum rate of change, is a 0 for f double prime. So any of these fill in the blank types of questions are also fair game. So again, if we come over here and I'm showing you a graph of f, okay? Different than the last video where I showed you a graph of f prime. I'm showing you a graph of f, and I'm asking you to fill in, and I put them out of alphabetical order, A, C, B, because that's the order they are here. But what do we know about f and f prime at each of these points? Again, try to fill this in without me, and then come down here and tell me something about point D and point E. Okay, because I could do two things. I could give you the graph, you could fill in the chart. I could give you the chart, you tell me about what's happening at those points, right? And this question sort of intermixes both of them. Okay, so anyways, at A and B, anywhere I have a turning point, first derivative's positive. Okay, but if I have a turning point and it's a max, then I'm concave down, right? So a max, the second derivative is negative, right? Because I'm concave down at a max, always, if it's a differentiable function. I'm concave up at a min, right? So the second derivative would be positive, okay, because I'm concave up. And then C, this point is halfway between where I'm concave up and concave down. So I intend for C to show an inflection point. So the second derivative is 0. Well, what's the first derivative here, right? And notice, because my function is decreasing, the the first derivative would have to be negative. Anywhere that f is decreasing, the first derivative's negative. Now I come over here, second derivative is 0. Okay, so that means inflection point. But what else do I know? Right? And what else do I know is that my function is increasing. I have an inflection point where the function is increasing, right? So I can have an inflection point on an increasing function or a decreasing function. All right, so that's telling me that now my function goes like this, right? Here's another inflection point at D. And then at E, anywhere the first derivative is 0, that shows me turning point, right? I have a turning point, and since I'm concave down, right, to have a turning point where I'm concave down, this point must have been another max. Okay, so these are all the different ways that I can ask you to show me that you understand the relationship between f, f prime, and f double prime.